Okay, I think we're going here. We're going to do two main things today. One, we're going to look at the Recreator 3D. I've got it loaded with filament, or not filament, got it loaded with plastic bottle to make filament. So we might look at that a little bit. Last time we couldn't get it loaded right, and I think I know the reason was that bottles, you know, these kind of bottles, they just have all these little ridges in them, and I did not straighten those out. So I found a bottle that had a clear section, like no ridges, and that seems to be working pretty well. So you really do have to get the ridges out of them as best as you can. Something like this to pressurize the bottle, you know, like this, and heat it up to smooth all that out. But I found one that had a smooth section, and that seems to be working okay. It's not very much, so I can't make a lot of filament, but at least we can show how it would work ideally. And then the other, so that shouldn't take very long. It's just kind of, hey, here's wrapping that up. Most of what we're going to do is we're going to be in a bunch of software packages trying to take scan data of a 2008 Ford Ranger that I scanned with my iPad. So I used Polycam, and it's a LiDAR or photogrammetry, but I used the LiDAR mode and scanned the hood of it. And we're going to try and use that scan data to make parts in, we're going to use Fusion 360 as the main modeling part. We have to use a couple other programs just to kind of get it there, but we'll walk through that. So let's go over here and look at our Recreator. So I've got, you know, a little tiny piece of bottle, but you can kind of see this section has no ridges of any sort in the plastic. It's all smooth. I'm not sure if it's going to be able to pull it through the cutter. So this is the little thing that strips it into strips of plastic. I'm not sure that there's enough torque from the little stepper motor to do that and pull it through the hot end and wind it up. So I may have to, you know, do some manual slicing or something, because it is a little bit difficult to pull through there. But just pulling it through, you can kind of see it makes these little 8mm tall slices. 8mm because of the thickness of the plastic. I'm trying to get the same cross-sectional area that you would have in a 1.75mm diameter piece of filament. I need that same-ish cross-section in the rectangular strip here, so that when it comes out, it's roughly the right diameter and right amount of material. So I've got it heated up, and I don't remember, I actually think I might have had to heat it beyond, it's supposed to, the instructions say to use 210 here. I think I actually had to maybe go a little higher than that. Let's see if it's pulling out. I'm going to go a little bit higher than that, because that is a little bit hard to pull out of there. I assume once you've figured out what bottle you're using, then you have a better idea of what temperature to run it at. But it comes out here. So all of this was manually pulled out, and you kind of see it's got little bumps in it where I had to grab it and pull on it. And then it wraps around here, and this will start turning once I tell it to. I haven't actually told it to start feeding. Let's go. You print a file. So on the little screen over here, print, start print, and you can kind of see it's starting to pull. And it's going. I'm trying to hold here so that it wraps around a little bit, but I think it, yeah, if I don't do that, it won't hold itself. I should clamp it back on itself or zip tie it, but we're not going to do that right now. We're just trying to make it do. I don't even have a lot of filament it can make. Once it gets a wrap or two around here, I think it'll be okay. But you probably can't see that filament is coming out, but you should be able to see that this is turning and it's taking up new filament, and it's coming from here. You might can pick up that this strip is, I'm currently not having to slice any new bottle yet, because I've pulled some through. In a minute though, I'll run out of this, and we'll have to see if it can wind it up and slice at the same time. I don't know if it's got enough torque for that. We've almost got a whole loop here. You can code different speeds, different take-up speeds. This is probably kind of in the middle average. There's a lot of tension on there. Yeah, there's a lot of tension on there. I wonder if I can get it to wrap around over itself to kind of tie it in a knot there. Maybe. The new filament that it's actually pulled versus what I pulled through actually looks really nice. I don't know, maybe I can get you in a little closer to it. Kind of. Oh, and it is slicing our bottle back here. I know I moved you too close. I'm still holding this because I don't, yeah, it hasn't really wrapped around there. I might have to let it come out here, and I wonder if I can pause and re-tie it. Let's pause. Let's see if we can get it to. Actually, you know how this how this code is written. Pausing might not actually do anything. So we can do that. Let's just tie it on there. That should tighten itself up. So let it go a little bit. Think that'll hold. I saw some of like the instructions for the guy that built the machine or designed the machine. He used a cable clamp to clamp it back on, clamp the filament back on itself, and that seemed to work pretty well. I just tied it in a knot just now to see if that'll help it hold. It hasn't gotten to the, oh, it's about to take up the slack. That seems like everything's moving as one piece now. So we're slicing filament here, heating it, pultruding it is what the word they were using for that, instead of extruding, because you're pulling it through and taking it up on here. And you know, it looks, our little fan here doesn't seem to be on to cool it. Maybe I have to manually turn it on. It must not be written in the let's see if I can tune it to turn the layer fan. Yeah, it's at 0. This little fan may not be cooling, so that might be affecting the diameter of it. It seems perfectly cool on this side. I think it is rough right here. There's a little rough edge. That it's not rough on this side of here, so it seems like going around this guide wheel is roughing it up a little bit. It's not a lot, but there is a little bit of rough edge there. But it actually seems like it's working. So that's pretty cool. So now we can, assuming I can find some, or either find or create bottles that are smooth versus the rumply kind, then we can have some PETG filament. Maybe I'll get one of the green bottles like ginger ale or 7-Up or something that will make us green filament. I did have the idea that we might can dye the filament like I tried to do with this. Maybe some of the synthetic dye, RIT dye, could actually dye this filament. I might try that too and see how that goes. Let's see. I did print another vase. This vase is Prusament Galaxy Purple. I had found a sample of that I had. I also have a Galaxy Black that's black with metallic in it. The Prusament stuff is really good filament. It costs a little more. Sometimes it takes a little longer to get in from ordering, but it prints really well, and it looks really nice too. So if you ever get some Prusament, it is good. In the printables.com, you can actually get free Prusament by completing little tasks in printables.com. So printables is similar to Thingiverse, but it's built around Prusa, and there are little things you can do, like fill out your profile, download some things, upload some models, print models and things like that you can do to earn points. I don't remember what they call the points, but you can earn those points. You earn enough of them, then you can get a free roll of one of their Prusament filaments, and they are really nice filament. All right, I can't let this run too much longer because we're going to run out of bottle soon. So I didn't get a lot of filament, but we did get it to work. That was the main goal for today on that end. So I think I'll let it go for another minute while we're working over here. Let's just go here. So we're gonna do some form modeling. So we're gonna start in, I think I'm gonna start in Blender. So all of the stuff we're gonna use software-wise, other than Polycam itself, is either open source or you have access to a free version. Like Fusion 360, you can get an educational version. Blender is just open source free, and another one, what is that called? Instant Meshes is open source free. So those are the pieces of software other than the one to actually collect the data in the first place. So I did use Polycam, which is not a free app, but there are other apps that either let you have some free time on them, or you can do the photogrammetry process, which we've talked sort of a little bit about. I don't know if I spent a lot of time with it. We might need a whole day on photogrammetry to get the geometry in the first place. So all I did, I don't have my iPad out here, I don't think, but new iPhones, newer iPads, and some other phones have LiDAR sensors on them. So LiDAR is time of flight of light, and it's a distancing technique. So basically it shoots out light and it bounces off something, comes back, and that time of flight tells it how far away it was. It's kind of like sonar except with light. A lot of the newer phones have that sensor built in. They use it for, like, open your phone with your face and stuff like that. They use it for that. But you can also use it for scanning. And Polycam is probably the best app that takes advantage of that for phones and tablets. So I did that, and I scanned the front of a 2008 Ford Ranger. And part of the downside of using at least that particular app is that when it scans, you're walking around aiming your phone or your tablet at the object you're scanning, and it's collecting data the whole time, and then it puts it together, but it puts it together in pieces. So there are all these little patches of scan data that are kind of stitched together. So that's the first thing we want to do, is we want to go to Blender. This is Blender. And we want to weld all that together. So this little cube is not our scan data. That's just the default cube that, for whatever reason, whenever you start a new project in Blender, it drops that in there. So we're going to delete that. I think I want to shut off our Recreator. We're about out of filament, I think, or out of raw material. And again, I hit the stop print. I don't know that it actually stops. I might have to just turn it off. Oh, there it went. All right, print aborted. So we did get a couple of wraps of filament there that we can maybe print a tiny little cube with. Like I said, I'll try and get a bigger bottle that's more smooth, that will work better. All right, so we're going to import our scan data. So file, import. I saved it as an OBJ, an object file, and I put it on the desktop and in some folders. I did it July 20th. There it is. All right, so this is the rough data that we got. So I'd like to clean it up a little bit. So you can tell it's a truck. I did not focus too much on trying to get this smooth because I'm not interested in that. We're going to work on the hood up here, which is roughly smooth, kind of not too bad anyway. We can tell what we're working with. But if we go to select by type and select the surface. No, that's not. Oh, no, no. Select. What do I want to do here? Maybe I need to be in edit mode. There we go. So you can kind of see there's our mesh that we have, all our little triangles. And they're not bad. We could work directly with this, I think, and be okay. But I want to do a little bit of cleaning on it. I never remember which set of keystrokes are going to move which way on here. So now I think I select by trait. There we go. Non-manifold, so not joined together. And you can kind of see all the different patches that exist. These are fine, except the next process I want to do to try and clean up the mesh, or, well, clean it up and simplify it. It works better if they are not like this. So I'm going to go into, I think it's mesh. Is it mesh or vertex? I don't use Blender a lot, so sometimes I forget where things are. Let's see. And if I can't remember, it'll be fine. Merge. Yeah. Mesh, merge by distance. So basically, vertices that are close together, all these little orange ones are doubled up, really, because they're the edges of two different patches. So they're close together. So if I merge them by distance, then vertices that are close together will get stuck together. And I did that. And I don't know if you can, yeah, it's off the bottom of your screen. Down here it says that I removed like 3,000 vertices. So now, even though it still shows these patches, they're all one big patch. So we will export that as a new OBJ file. Let's put it directly on the desktop, and we'll call it truck merged. There we go. And we'll export that. I'm not changing any default settings. All the default settings of export and merge distance and all that, I'm just leaving them as default. All right, so that's all we need to do in Blender. You could do more, like we could try and chop off some of this mesh that we don't want to use, take the wheels out, whatever. We could do all that here too. Blender is a different kind of model. It's a NURBS model. I do not remember what NURBS stands for, but it's basically, it is not going to operate the same way as something like SolidWorks or Fusion 360. It's not a parametric modeler like that. It's based on, it's really good for smooth, rounded, organic type shapes. And it can work fine with the stuff that you would expect SolidWorks to do. It just is a different workflow. So all I wanted to do here was use it as a mesh tool. I probably could have brought it into Mesh Mixer and done the same thing, but I did it in Blender. So I'm going to close Blender down. I don't think we need to save. We didn't make any change. Well, yeah, we did. We merged it together, didn't we? But I'm not going to save it. Now let's go to a piece of software called Instant Meshes. Let's see, that's Fusion. We don't need that one. Here it is, Instant Meshes. So it's just a folder with that and data sets in it. So this is Instant Meshes. So we're going to open a mesh. It can only open the polygon files and the OBJ files, and so that's why I exported it as OBJ versus like STL or something like that. So there's our merged file. We'll open that. And we're looking at the back of it, so let's turn around. There it is. Shiny blue in this one. And what this one's going to do is it's going to take our geometry, and remember how we had thousands of little triangles. I don't even know how many little triangles we had. I guess I could have looked, but thousands of little triangles. And it's going to turn them into a coarser mesh. So I'm going to lose some detail, but in this case, what I want to do with this scan data doesn't require a lot of detail, so I'm not worried about that. I'm going to turn it into quads. So instead of triangles, I'll have quadrilaterals. So they have 4 sides. I'm gonna keep it at 3,000 here. So the target is about how many vertices do I want. I could increase that or decrease that. I'm gonna keep it somewhere in the middle-ish. That's fine. And this solving orientation field this is kind of how are all of those meshes oriented in there. This is what, if I had not merged the individual patches from the scan data together, each one of those patches would have its own orientation, and I'd end up with a mismatch of quadrilaterals all over the place. So this will kind of align them all together. In fact, I can check and see position field. I can solve. That looks, you know, they look very orderly here. Had I not merged it, this would be a bunch of different patches in all different directions, and it would not look orderly. This actually looks pretty good. So I could manipulate it if I wanted to. I've got the combing tool here, and I could go in and maybe specify a crease or an edge or something, but actually I'm only going to be interested in the hood up here. So that looks really, really nice. So I'm going to export. I am going to just extract. There's the mesh that's going to generate. So it's much lower polygon count than it had before. And there's not a lot of detail in the front, but again, I'm not using that. I really just want this up here. And it's got one little weird one right there, but we're going to be okay with that. Let's save. Now it does have a weird little quirk in saving, so you have to put the .obj in here, otherwise it gets really confused. So truck, whoops, remeshed .obj. If I don't put .obj, it gets confused. All right, so now we've got that. We can be done with instant meshes. That's hard for me to say for some reason. And we can go over to Fusion 360. All right, so now we're in Fusion 360. Looks like I'm off the edge. No, that's something else. All right, we can close that or minimize it. So here, normally Fusion 360 is a parametric modeler like SolidWorks, and you build parts from operations like extrude and revolve and cut and trim and all that kind of stuff. And we're not going to take that route. We could do this same type of thing in SolidWorks, but I have not had as much success doing what I want to do here in SolidWorks as I have in Fusion 360. So I'm going to use Fusion 360. Even though I know SolidWorks better as an overall tool, this particular piece of Fusion 360 seems to work better than I can get it to work in SolidWorks. So we're going to insert a mesh, the one that we just created. So I've got to put it on my computer. There it is right there. There's the preview of it if we wanted to see that. And we've got this little guy here. I'm going to show the origin because I do want to line it up. Like right now it thinks that's the back. So let's orient it to where it makes a little more sense. So the top, I want the top that way, and I want that to be the back. That looks like the right side to me, but that's fine. I guess we could flip it over if we wanted that to be. I guess we could do that. Well, it's going to be fine. But I do want it to be lined up with the origin, so let's manually line those up a little bit better. Just that'll help with rotating things around. Although this center doesn't. Let's line the truck up that way, because there is a little. You can barely pick it up. There is a little indentation in the truck there, and that's what I want to be lined up with the origin. Okay. That seems good. The unit types. So Polycam, I think it does export in millimeters. I think. 100. I'm not 100% on that, but I think it does. That looks good. Now we could, let's get rid of some of this extra mesh just because it's distracting. And you might have some reason you want to do that, so we'll do that. In here, it actually doesn't hurt us, but let's go into there is a mesh tab, and there's a direct edit. So we can directly edit our mesh here. And we can just, well, let's do a lasso select, or freeform select is what they call it here. So let's just kind of select those guys. Oh, I don't want those though. Let's just see if I can do a better job of not getting the truck parts. There we go. Well, it's going to pick some of them anyway. I don't know why it's doing that. I guess they're just too close. Huh. Not sure why it really wants to pick those. Let's go back to our paint and just paint it on there. And hit delete. Let's get rid of the other one. We can get those. There we go. We could clean it up a little bit with a window select and just kind of chop the bottom off. I think we must be in a weird, let's see what, we're in perspective, that's why it's looking that way. I normally like perspective, but in here I'm trying to do, you know, nice and straight, so perspective kind of works against that. Alright, so you could go on cleaning up as much as you wanted to. It looks like we have one stray one in there. You can only select them from the front side, so you got to find where their front side is. I think there is select back faces. You could select that option. Alright, so let's, oh wait, we're on paint. Let's chop some of that off. There we go. Alright, so we've got our main little part there. So finish direct editing. Now, what I just want to use this kind of as a form to work on. So we are going to go, and what we're going to try and do, I didn't even tell you what we're trying to do. So let's see. We're going to try and make some sort of hood scoop, kind of like this one on this old Plymouth. And something it's styled like that, but we want it to match our 2008 Ford Ranger hood that we scanned. So that's kind of what we're going for, is some add-on that we want to maybe print it. Now I'm not currently thinking about making the hood scoop printable. So that would involve some other decisions, like what orientation are we going to print it in, how big's our printer that we can print it on, that sort of thing. I'm not going to think about that yet. Those are good things that we probably should be thinking about if I plan to print this thing, but let's leave that for another one and just worry about how could we even make the design right now. Then we'll, later on, if I actually want to print the thing out, I'll go through the idea of, well, how would we make this printable on the printers that I have access to. So that's what we're going for, something roughly like this shape. So you could imagine that you might want to go in and, you know, go straight over to your solid modeling tools that you normally use with extrusions and all of that. And you could do that, but we're going to use the surface tab here, and we're going to use a form. So a form is more manipulative versus modeling. So it's more the kind of modeling where you're moving around lines and edges and vertices, and you're adding edges and things like that. So it's more of an artistic way to design something versus an engineering way to design something. So we're going to use form. And I have a whole new set of tools here. Mainly, we're going to start with a plane. And there's a face over here that we could also work with that works similar. But I don't know, we're going to do a plane. So we're going to make that plane parallel to our top plane. And then we're going to try and line it up center, because I want to use symmetry, because I'm going to assume that our hood scoop is symmetric. So I'm just going to start with some, you know, roughly something hood scoop-ish shaped, but it's just a plane, so it has no dimension at all. And we're going to make sure that symmetry. Oh, why is my symmetry? I want it to be mirrored on the length, I believe. Yes, so it added that little green line. That's our symmetry line. Then that's the one I want. Width would make it mirror along that line. Okay, so our plane's nowhere in the right spot, so we're going to go to this little move copy and select our plane. And if you use the arrows here, they move in just one axis at a time. The rectangles will move them in a plane. So I'm just trying to get it kind of hovering above the hood. Whoa, I pushed the wrong button. So something like that. And I don't want it touching the hood yet. I'm going to model some, and then I'm going to pull it down to the hood because I want it to kind of conform to the shape here. That's one of the reasons I need some representation of the hood, is because I want it to more or less fit. If I were to print it out, I want it to fit without a lot of modification. I want a nice seam there. So that's why I'm really only interested in the shape of the hood here. But for now, we're going to float kind of above there. And we're going to work a lot in the coordinate views. So top, front, right, to try and keep things not perspective. Every now and then I'll switch back over to perspective mode to get a better idea of what it looks like. But most of the time I'm going to be in orthographic mode. All right, so now I can start modifying this. So I think it should taper in, even though it's kind of hard to tell if that tapers inward and it's wider at the front and narrower at the back, but I think it is. So we're going to kind of do that. So we're going to just select that little corner, and we're going to use this edit form tool, and I get one of these gizmos, and I'm just going to eyeball it, pull it in. And since we have that symmetry on, it'll match the other side too. Okay, that seems good. Still a flat plane though, so we need it to come down some amount. We don't have enough edges in here to do that right now, because I need some more edges. So if I double click on this guy, it'll select all in that, what it thinks is that edge, which is also what I think is that edge. Modify, insert a new edge, and I can drag it into place. This little number here is a fraction or a percent, decimal version of a percent. So it's basically saying 23% of the distance between the next edge and the edge I selected. I'm just going to eyeball what I think. I want it to round over, something like that. We'll hit enter. All right. So here is Alt 1. So it depends on if you're on a Mac or a PC. I'm using a PC. So you might switch out Alt with, maybe Alt is the same and Control is different. I don't remember. But I'm on a PC. Alt 1 is what's called the box view, and Alt 3 is the rounded view. Now, they're both just flat planes right now, but you can kind of see that those control lines end up in different spots in both of those views. It is better to do most of your work in the box, the Alt 1, like I'm in right now, and then check it in your rounded view. You can model in the rounded view if you want to also, but it's better to model, add edges and move points around in the box view than it is to do that in the rounded view. All right, so let's pull this edge down. So I double clicked on it. I'm going to come to the side a little bit. Actually, yeah, we'll pull this down now. I'm trying to think of the order I want to do things. So we can modify, and we can just pull that down, something like that. And again, I can look at it rounded, and I've got a much rounder one. Now our version here is not very rounded, but this the cars in the 60s, a lot of them had more angular features than they do. The 2000, I don't know if you know what a 2000, well, I guess you have our scan. So the 2008 Ford Ranger is a lot more bubbly. It's a lot more rounded shapes. So I kind of like this rounded versus sharper corner here. But if I wanted to create this sharper corner, then I would just need more lines here, more control lines. So I could insert another edge, maybe pretty close to it. And now when I go to, this is the rounded preview, now notice it pulls that as a sharper corner. And I can make it even sharper by modifying where that You know, I could make it a lot sharper. There's the box view. There's the rounded view. So if I wanted that sharper corner, and I could tighten, I could add another edge. You know, I could keep doing it to make a more tight transition. I can also make this line a crease. So I can crease that line, and now I get a sharp corner. You know, there's no rounding at all there. So I could do it that way if I wanted a really sharp, but I don't think that matches. Notice how the edges of the truck itself are pretty rounded, so I don't think I want the crease there. So I'm going to undo the crease. This is not so bad. It's a gentle curve, so I might keep that. So we got that. This is sort of a double. You know, it's got this little feature in the middle where it drops down, so we're going to have to add some lines to make that happen. So let's go back over here. Let's go to our box view and the top view and add some more control lines or edges. Maybe there. And let's add another one. Kind of close to that one. And let's take these surfaces, so just holding down shift just like both of them, and let's move those down. So something like that. Maybe. Let's check our rounded view. Now that's a little too rounded in there, I think. So let's go back to box view, and I don't think I want to crease that edge. I think I just want to add another control line to make it not round over quite as fast. And I think I need one at the top too. So let's add another one up here. Actually, I think I might need it on the other side of that. That's looking pretty nice, I think. Pretty good. Now let's look at our, let's look at our thing. We've got kind of that shape. Oh, I was trying to rotate this picture. I can't do that. It does, I think these kind of come forward. We might work on that. We might not. It does taper also. Now some of that taper is going to be when we bring it to match the hood shape. But I do kind of think I want this back part to drop down a little bit. So this could be a little tricky. I should have done that earlier. Actually, let's just move this line and this line. So I'm holding down shift to just select those, and maybe that tiny guy right there. You can easily get lost in the, you know, where all this stuff is. So now we've got more taper. See what that does to our, that's looking kind of, it's open in the back, which I don't really want that. We might have to create a little closed off portion here. Maybe we should work on that. It's getting confusing on me. There we go. So I've got 1, 2, 3, 4, 5. So if I had 4 edges here, then I could, well, I guess I would have a 6th one down here when I close it off. Let's see if we can bridge this. I don't know what we'll get. Yeah, it doesn't like that. Maybe we can insert points. Let's see if we can just manually connect those. Doesn't like that either. So let's do it a little piece at a time. I don't want to get... Oh, I didn't even like that. Why did it not like adding those together? Well, you know what? We could insert... We could possibly pull this edge down. Holding down Alt will, instead of moving the edge, it will, when I move it, it actually just creates a new edge. So we could do that. Gotta see if I'm, yeah, that looks okay. Now we should be able to close in this little gap with maybe just insert point, or actually we could merge those points together. So not merge edge. I thought there was a merge weld vertices. Let's do that. There we go. So those are connected. Now we got to figure out what we're going to do over here. I want that little node is helping control the round over. So I think maybe we will try to do that. Doesn't like that. Okay. I don't want to merge those. I don't know if fill hole will. Oh, maybe if I do connect these guys. Nope, doesn't like that. Already tried that one. I'm not sure the best route to fill this guy in. I don't think it's going to bridge very well. Oh, I didn't like that. Well, we might come back to that and not worry with it at the current moment. Another thing I could do is I could move this edge all the way down to there. That might be what we need to do. That would be a weld vertices if I can find it. Oh, I want it the other way though. I want that one to move to there. There we go. Now I might can fill that in. Or I might can just weld those. Maybe we can weld those together. Alright, so now we've got it closed up in the back. Let's look and see what it looks like rounded. Now, see, I've got some really weirdness going on here. Like these lines, that's not great. If it will be okay for what we're doing, because we're not, you know, trying to be too worried about that, but it definitely is not great for the geometry of the model that we're working on here. So we probably should be a little more careful about how we close up this back part. I think I'm going to let it be for now because I don't want to spend a whole bunch of time on it. And we're going to move on to the next step. So we do need to match this to the hood. So let's get the whole thing. Oh, cancel that. Oh, wait, that was my weld vertices. Let's actually not cancel that. Let's do that. Although it's making it kind of weird, but we're going to do it. Let's select the whole thing, and let's get it closer to the hood. It's too far away right now, unless you wanted it that tall. Let's get a little closer. Even that's going to be pretty tall. We might have to manipulate it down a little bit longer after we've done this. All right, let's go there. So what we're going to do now is we're going to pull these corners down to the target, which is going to be the hood. So there is a pull command, and you pick a you pick a target. Target's going to be the truck, and the edge that we want to pull is that one. And so it pulls it down to the nearest point on the truck, or whatever the mesh is that your target mesh is. It's not always perfect, but it's going to be close enough. That one clearly went way crazy. But maybe if we... Oh, wow, that one... Yeah, so the first one worked okay. But after that, we may have to manually pull. So, pull that. Yeah, that one wants to go way out there for some reason. let's see if, all right, that one, not sure why it chose there as the closest point versus just straight down. Doesn't always make sense on how it decides to choose things. Yeah, so it's doing some weird stuff. Let's just manually pull it down. So let's just take individual points and manually go straight down until we're happy with them. Because now you'll notice I'm going into the hood here because I did a really, first of all, it was a really quick scan, and the LiDAR on that tablet doesn't do super fine resolution. There's some noise in it. So I'm not terribly worried that I'm intersecting the hood here. I just want to get close. And I might even need some more because it is more rounded than what I have got here. And it might have gone off the back of the hood actually right there. That might be, the problem is these might be too far back because there is a cowl back here where, you know, the vents and where the windshield wipers are, and I might be overlapping that, I think. So let's undo that. Well, no, let's undo that one. And let's move all of these. Whoops. Let's hide the body. I don't want that one right now. I want to just select well, can I do that and then move? Let's select points instead of over there. There we go. And let's just pull them all forwards a little bit. I think this little dip right here is representing the cowl. So I'm still really close to the back of the hood. Let's go back to my process I was using. Hide that. Oh, there we go. And let's only select the points. And let's move them back a little bit more. All right, that should be good. Now we could fiddle, you know, all day with making it work just exactly the way we want to. Let's pull these down and then let's go to the next step. So you could keep editing and moving around points and whatever you wanted to do to make this thing, adding more control lines to make it more the way you want it. But let's not get too carried away right now. Probably should have moved those together. All right, so let's say that we have got it matching the way we want it to. Looks a little tall in the front. Let's look at it in smooth. That doesn't look horrible though. It actually could be cool. Might be a little big. I don't know. Let's see, there's some other views where we can just be shaded. So there's kind of, so this is Control and 4 will get you no lines, just shaded. Control 5 will add the mesh. Control 6 adds just the lines, not the mesh. And then you've got a wireframe. So Control 4 will give you kind of a shaded view of everything. Control 6 is what you're normally used to. And then there's our box view and our rounded view. So let's say we've tweaked it to the point that we're happy. Now we need it to have thickness. It's just a infinitely thin set of planes now. So we can add thickness, select the whole thing, modify, and there's a thicken command. You generally want this to be towards the end of your process. We're going to make it 5 millimeters thick. That seems reasonable. Wow, I don't know what that did. So, not sure what it's doing there. Thicken type, I want it, do I want a soft? Well, let's do soft, but I don't think that's what I want. Yeah, not sure why it did that. Let's try that process again. I want it to thicken the other direction. Wow. Oh, you know what? If that's 5 millimeters, then our scale must be really off. I didn't think about that. We must have imported this as the wrong units when we first brought it in, because that's definitely not 5 millimeters, right? So we need probably, oh wow, we probably need 0.005 millimeters. Yeah, that's what we were on, 1,000 scale. Let's go back to normal though. It is transfer. Oh, so let's go negative so it sucks it in, just so that we maintain the outer geometry, because what we were modeling before was the top surface, right? So let's make it thicken towards the inside. So if we make it thicken with a negative and then 0.005, we'll have to scale this at some point to make it the right scale. We're gonna do soft, but that's probably gonna mess up these corners. And I'll just show you what happens. So it looks fine here, but when we go to the rounded view, that's not what we want. So let's undo that, and let's thicken it with the hard edges. Now we could add more add more control lines around that perimeter, and that would be one way to have it not suck it all in that way and make rounded edges. I don't want too many rounded edges, so I'm going to thicken and use the sharp. I do want an edge. I don't want no edge. No edge would basically just offset it. So this is what we have now. I probably do, like, I don't know if I want this so creased right here, so we can go in and take that loop, insert an edge, and that looks great like that, and we can pull that edge out, I think, and make it not so crazy. Like if we move this just a tiny little bit out. Now we've got a nicer rounded front on that thing, and we could add something like, we can make it more extreme if we wanted to. I just think that making it a sheer cliff there looked a little weird. We need some mounting, so let's hide the truck body again, and let's thicken up this guy. Let's not do the back though. Let's only do this one and maybe that little section. Let's do those, and we will just move those and pull them in. I probably don't want that one. We may have to, that's going to make the front edge pretty thick. I don't know if I want that. We may have to modify that, but I need something, you know, to bolt holes or glue body panel glue. Somehow I've got to mount it on the truck, so I need some surface here versus the 5 millimeters. So let's call that good. And I think what we can do that would make it kind of interesting is take this and pull it in some. Maybe that one too. And pull them that way. That would look kind of cool, I think. And let's check our rounded view, because, oh, we were in rounded view. There's our box view. There's our rounded view. All right, so now we've got stuff to glue to or screw to if that's what we wanted to do. The back, we probably need something there. We're not going to worry about that. We're getting close on time, so you could keep going and, you know, making this thing how you wanted to. It's a very different modeling process from what you typically do in SolidWorks or even Fusion 360. So it is a little bit to learn how to make these pieces of, you know, software do what you want them to do. But let's say that this is what we wanted. When you click Finish Form, then it's going to convert it over. So it could change a little bit. So it's going to convert it to, from these lines or forms and planes over to what are called T-splines, I believe is what, or B-rep. I don't remember which it converts it to. But it converts it over, and it might change a little bit. So you might have to check it out and make sure that it didn't change it in some way that you're not happy with. But now I can do my regular modeling on it. So let's hide the truck again. And let's say that, you know, I'm afraid that it's going to be kind of wobbly in here, and I need some ribs to brace it. And I didn't model those in, but I have a tool. I have a solid tool for creating ribs somewhere in here, right there, and webs if I wanted to do that. I can even emboss. I could put some lettering on the outside, or emboss or deboss a receiving part for inserts of lettering or whatever. But I want to make a rib. So that's relatively easy. We need a reference plane. Let's make it parallel to that, and I guess our units are going to be kind of weird, aren't they? Let's see, -1 millimeter. Where's that at? So 1 millimeter is way over there, and negative's backwards. So let's do positive, and let's make it 0.5. All right, that one's near the back. That's probably okay. Let's make another one. From that reference, let's make that one further away. There we go. And we could keep making planes to make more ribs. I don't think we need to overdo it as far as the example goes. So now I have 2 planes, and I can have a whole bunch of them anywhere I wanted to add some feature. So to create a rib, you have to draw a profile. Since we have symmetry, I only have to draw it on one side, and then the other side can just be the symmetric to that. Let's make sure we're in orthographic, and we're just going to create a sketch on maybe that back plane. Make it where we can see this. And for a rib to work, it has to intersect the model that it's going to be projected to. So I'm just going to take a spline, and I'm going to start somewhere over here. I'm going to kind of eyeball it. Something like this. We could have it go all the way down to the surface. It's kind of hard to tell where the surface is going to be, though, so I'm just going to call it good there. And let's make sure it intersects. So it pokes out there. You can kind of see, I don't know if you can tell or not, but it changes color a little bit where it's inside versus outside right there. And that's fine. And then the other one, I think it pokes out. I've lost it. Yeah, it pokes out right there. So it's a brighter blue and a greener blue inside there. All right. So that's a rib profile. So let's finish that sketch. And let's go and create the rib. And the profile is the line we just drew. I'm going to make it thicken on both sides. You could have it thicken on just one side. And the thickness is going to have to be really small, 0.005 millimeters maybe. We need a preview. Okay, there it is. Is that too thick? Oh, that's so yeah. We really should have scaled this properly. I didn't even think about it being off scale. That's pretty thick, but I think that's 5 millimeters. Let's make it 3 millimeters because that does look kind of thick. So it thinned it out some. Maybe we can get a fillet in there. It's going to have to be, if that's 3 millimeters, maybe we can do a, nope, that's too big. All right, so there's a little fillet. Can we do more than that? All right, there's a 2 millimeter fillet at the base. We could add a draft angle. Like if this were being injection molded, you'd want a draft angle so it could come out of the mold. I don't really need one though. If it didn't make the rib in the right direction, you can specify where you want it to project that profile to. In this case, it picked up that it was the right direction, so I don't have to change that. So, okay. And now I've got one little rib modeled in there. Now that's a modeled feature. It's in my timeline down here. So there's the rib. And so that means that I can select it, or I can select the feature itself, and I can mirror. Mirror is in create, isn't it? Yeah. So I can mirror that object, and the mirror plane, since I built this in relation to the origin, I can mirror it over there, and now I've got one on both sides. So we'll do that one more time, and just because I have this other plane here. So you create a sketch on the plane that you created. You draw your spline. It doesn't have to be a spline. I just picked a spline so it could be curved. Make sure it intersects the part that you're trying to make the rib go to. That one intersects right there. You can move it around, so you can just drag these around if you need to. And make sure it intersects over there. Actually, let's make that intersect a little lower. Does that I think that intersects. There it is. It's intersecting right there. All right, and then we will create rib. It should keep the selections that we had last time. But it did not, or something it doesn't like. Or maybe it's, oh, let's try flipping the direction. No? Oh yeah, there it goes. So that time I did have to flip the direction. I guess maybe the way it intersected over here, it wasn't sure if it was supposed to wrap around to the other side or something. Hit the flip selection direction, and that looks like what I wanted. Now again, I'm not thinking of these as 3D printable. I'm just thinking of, you know, reinforcing the thing. It's not mirrored. My mirror function is over here. I could take in my timeline and I could move that mirror to the end and edit it. And I should be able to, instead of just selecting one, should be able to select the, well, it won't let me, won't let me select that one for some reason. Not sure why. I'll just create another mirror for it. And I could have mirrored them all at the end. That would have been fine, I suppose. I was going to modify it and add it to our previous mirror, but it didn't want to do that. So we just did it this way. So you could keep adding features. You know, you could do the embossing. I think you can do embossing text on. Well, I didn't draw a profile to emboss, so I have nothing to emboss right now. But maybe you could write some text right here on a plane and then emboss it into the surface, or onto the surface, either way. So you can do your regular modeling tools once you finalize the form. You can go back and edit the form itself, but you have to be careful with that, because now that I've added those ribs, they might get broken somehow if I edit this in a way that would destroy the ribs. Let's say I want to pull this corner out front, because I wanted it to kind of, you know, do something like that. That shouldn't break my ribs, but you never know. Let's call that good, and let's see if it'll. Looks like it was fine, and I need to finish the form, see if my ribs are still okay, and it looks like they are. And I've got that kind of front leading edge. Probably need to thicken it up. That's a razor edge right now, but we would need to add a line to make that a little thicker. So we'd have to go back over here and take this one, well, just take the whole thing and modify, insert an edge, you know, somewhere in there. And now I could move that edge a little bit. And maybe also that one. And I probably I'm still at a sharp corner right there. I probably should round that over. See how it's darker black? Oh, I'm starting to get some weirdness here. Right? Let's undo those. See how it's a darker black color? That means it is going to crease, and I can modify, I can uncrease, and that will make it a rounder, but I could end up with other things that get broken when I do that. So yeah, I'm starting to get some weirdness down in there. So you can fiddle all you want to with it, and I think that set of tools would, you know, give you something that you might not have tried to do before. They're relatively easy to use, but they're finicky. You know, there's a lot of finickiness to overlapping edges and intersect. You can easily create self-intersecting surfaces and that kind of stuff. But now, I mean, that looks reasonable. That doesn't look bad at all. Not necessarily 3D printable, unless you had a really large printer and you can stand this on its end and let it print vertically. I think, I didn't measure this, but I think I could probably split it in half and print it on one of the printers at school. The really big printer could print it. It would still need some kind of support. In this case, I think I would build in the support versus using an auto support thing, or maybe just some other carefully designed ribs. It does need something to hold this front up at speed. I think at speed, since these are actually open, we would probably need to let some air out. So it either needs to go into the engine bay, cut holes in the hood, or we need some vents out the back. Which would kind of make it pointless to have the hood scoop unless it just was decorative. Anyway, there's a way that you could go and create some geometry that's a little more organic, free-flowing, curvy than what you are used to making with parametric modeling that we normally do. So maybe that gives you some ideas. This could be one of your optional assignments. I don't think you'd have to necessarily print something the size of a hood scoop. You can make something much smaller. But it's an interesting process that you might not have done. You should have the full access to Fusion 360 if you sign up with your .edu email. And none of these features are any of their special add-in features. These are built into Fusion 360. SolidWorks can do stuff like this. I just have never had as much luck using SolidWorks as I have using Fusion 360 for this kind of thing. All right, I will see y'all Monday, and we'll do something new. I don't know exactly what it'll be yet, but we'll do some other new thing. Maybe we'll look at the photogrammetry as a whole lecture by itself, because you do need, for this process to work, you do need to get scan data somehow. And that's a way that you can get it for free, essentially. You might have to wait longer, but you can do photogrammetry. There's some software that's free. All you need is a camera at that point. And your cell phone will work as a camera. So I will see y'all Monday.